Good day, guys. How are you doing today? Today we begin a new series on microcontroller programming and development. Today we look at what microcontroller is. A microcontroller is a compact internal IC, integrated circuit, designed to perform some specific tasks. So it contains several devices such as processor, memory, and timers, ADC, and together converters, and so on. They are built using semiconductor devices. And they're from silicon wafer process using photolithography and advanced semiconductor manufacturing techniques. So let's look at the overview of microcontroller. We're going to be looking at both Arduino and PIC microcontroller. Arduino is a company. So we have microchips. The PIC belongs to microchip. So Arduino board typically use hardware, microchip AVR or ARM Cortex M processor. This PIC is developed by microchip technology. You can see, but Arduino is very easy to use as compared to PIC, using MPLAB SIDA. The word and the language, programming language supported. Arduino, you can write Arduino programming language, you can write Arduino code with C or C++ code. And you can also, which contains a set of libraries. Also, if you look at microprocessor, it's my PIC microcontroller, I'm sorry for that. You can also use C, assembly language, and C++ in it. You select it, and then we get a demonstration, we're going to see how it's being done. The architecture of the Arduino programming or Arduino, we also have ATmega328. It contains 28 pins, ARM Cortex. So also, before I leave the programming languages, you can also use Rust programming for Arduino. You can also use Rust to the edge of Cortex, start from the library, from the crates. You're going to use Cortex M crates from the Rust library. You are well grounded in Rust. You can use Rust for that. As well, you can use C++ for PIC development. So it's written here. So, and the two of them stop at 32-bit for now. 32 bits. 32 bits. They also PIC also 32. Also the clock speed. We also have 60 megahertz. We have 8 megahertz or 80 megahertz. Understand? So that is the clock speed through the help of the crystal oscillator. I'm going to be showing us from the board. We also have memory flash up to 2 MB memory flash. And this also varies from 512 megabytes to 2 MB as well. The RAM, 2 kilobytes, the range of that. So if you look at this, all these features, power consumption, moderately not, and you see highly optimized for low power consumption, like 3 volts and above, 3 to 5 volts. And also we have the higher pins. Only have 14 digital, 6 analog, and Honda. We also have Arduino, that's Arduino Uno. So Arduino Uno has in total is 28. Whether it is Rev 3 or Rev 2 you are using, so that's Arduino ATmega328. It's 28 pin. So this varies widely from 5 to 100 of pins. That is for whether you are using QFP or you are using DIP, PIC. Now we have ADC resolution. So 10 bits. Arduino has 10 bits, 8 bits to 16 bits, depending on the microcontroller you choose. We have 18F877. We also have 18F877A. Also, we have 18 series of microcontroller, 24 series of microcontroller for PIC. They are the mode of communication, UART. You can also have SPI, I2C integrated circuit, same here as well, with internet and Wi-Fi. We also have the Wi-Fi came also with Rev 4. So we have the timers, basic 8-bit, 16-bit. So we have the interrupt, we will then support interrupt. Now let's look at this, the features. Because of time, we want to shorten these. You can see the difference in these two microcontrollers. So we're going to be looking at these two microcontrollers. You can pause the video, please, I'm too fast, and you can see the area of the applications using prototyping, publish, project, IoT development, industrial automation using industrial automations. But there are other tools, other microcontroller you can use, but like a STMT, STM32, also ESP high DIF. You can also use those ones as well. But let's start from the basis of using Arduino and also PIC for our project. And now let's look at the tools we're going to be making use. The tools we're going to be making use of. We're going to make use of the tools like development tools, that the software that play roles. We also have the Arduino development. You can also go to Arduino website and search for Arduino and select the one. Maybe during time of installation, I will show us how to install those one. Okay. Then you can let's see the Arduino. Let's see this Arduino Uno Rev 3. Let's see. Can you see the conversion? This is serial out, this is serial in. This one for transmitting. This one for receiving, or for communication protocols. And you see, we also have our atmegram. We have the power LED transmitter. This is the LED, but then you're transmitting. This is the LED that showcase that. And you see communication with, in case you want to communicate with the other board, with other outside, maybe module or using other shield to communicate. Because in Arduino programming, any other module you connect to the other module, to the Arduino board, they are called shield, while the program itself is called a sketch. And so now, therefore, so we also have the other ports. We have the USB, we have the reset button. You can reset it, trying to turn again, you run your code. Here's the crystal oscillator here. Our crystal oscillator, you can also interface it with, you can also interface it with external capacitor of 80 to 22 microfarad capacitor. So same thing with PIC here. So we have our voltage, input voltage. We also have from 3.5 to 5 volts. Let's see, it's not clear into bits. So now we have so we also have, this is the microcontroller we're going to program. This is microcontroller. So we can also remove this IC. This is the starting point here. Can you see the notch here? There's a notch here. So see there's a notch there. If I increase it, the zoom in into this. So we can have it this way. And you see there's a notch here. So now let's continue with that. So now you can look at the informations. Also see this for PIC 4550 for example. This is analog. This is the first pin here. This is grounded with 10 kilo ohms resistor for power. So if don't, without setting up this, no matter what we do here, it's not going to come on. It's not going to display anything. So we have to what? Ground it with 10 kilo ohms resistor. And also with this reset button. The reason why I like PIC development over Arduino is that it exposes majority of those things that have been done for us by Arduino. Arduino hides some information from us, but the PIC makes sure that you do those things yourself. Here we have you have to power this with 10 kilo ohms, resistor. So this is the reset button to reset the state. We also have the reset button here. It's in Arduino. Now we have this an LED to just with four LED. You can see. That means we call this one with the power. We send low voltage. We send low voltage here, so to read so that because like the LED here will come on. We can also have the same thing. It went to some serial sections. We have A, we have pin A, we have these are the analog pins. Pin A, analog pin, or analog pins. Here we have analog pin compared to Arduino 3.28 or 328. We also have other pins. We have our PW, the pulse width modulation. They are the 2 pins here. These are our own, the crystal oscillator here. 20 megahertz, can be 16, can be 8. This the make use of 22 microfarad, as I said earlier. Can we make it start from 18 to 22 microfarad? to get clock good oscillation. We also have section D, another pin, and you see another pin here. So this is the starting point here. This notch mark the starting point. And you see a notch here. Same thing with the 328 here. This is a notch here. Now, therefore, you can see the various ID that can be used. You can also use platform IO with Arduino. So the platform also, if you have VS Code, you can just search as a plugin. And also, I'm going to also demonstrate it for us during the installation. Then we also have chilled. Can you see, as I explained the other time, all these are the chilled. They are the module that what Wi-Fi module, our DHT11, and temperature and pressure sensors. So we can include that into it. Let's look at the PIC microcontroller development tools. We have the PIC microcontroller development tools. The also advanced feature like debugging, code optimization, and real time. Also our compiler. The compiler can be SC8, SC16, and SC32. Then we have our PIC programmer. So we also have our microcontroller code configurator. If you want to use MCC, you can use that. So then that is the comparison of our. We also see the Arduino SIDE. So in course, but on the midst of continuing with this project, we're going to see a lot of things in setting up our program environment. So, and in setting it up, we're going to start again, continue. We're going to continue. So we're going to continue from next lecture on setting up the microcontroller programming environment. We're going to go to our website, the website for Microchip, and also website for Arduino to download and install the microcontroller. Thank you very much. Have a wonderful day. Please subscribe, like, and share.